In this video, I'm going to solve this question. In the first part of this question, we have to state the assumptions of classical linear regression model. Well, this is a theory question and all the assumptions of classical linear regression model are stated in chapter number 3 of your textbook. So you can take the assumptions from there. In case you want a quick review of the assumptions, then you can take a look at the 2 videos that we have on the assumptions of classical linear regression model. I have put the link to those 2 videos in the description of this video, so you can take it from there. Okay, so let's move to the next part now. Using data on sales of cameras and its price for 17 brands, the effect of price on sales is given by this equation. This is tested using OLS method and the results are obtained as follows. We have to assume that all the assumptions of classical linear regression model hold good. And in the part number A, we have to interpret the slope coefficient, that is this coefficient. Okay. So we are given that sales is the dependent variable and price is the independent variable. So let's see what is the interpretation of slope coefficient. So in this case, the slope coefficient of minus 2.375, note that there is a negative sign over here, so don't miss that. So the slope coefficient of minus 2.375 means that if we increase the price of camera, that is the independent variable. So if we increase the price of camera by 1 unit, then on an average, the sales of camera, that is your dependent variable, would reduce by 2.375 units. Okay. Now see, this interpretation is not 100% complete right now. I'm going to do a small change over here. The small change that I want to do is that I have written over here that if we increase the price of the camera by 1 unit, but what you have to be careful about is that what is 1 unit of price of camera? That is, what is 1 unit of this independent variable that you're given in the question? So it's given in the question that the independent variable, that is the price, is measured in the thousands of rupees. That is, this 1 unit is equal to 1000 rupees. Okay, you have to be really careful with this in the exam. Make sure that when you're talking about the independent variable and the dependent variable, then you write the proper units that are given to you in the question. Okay, so instead of 1 unit over here, I can actually write if we increase the price of camera by rupees 1000, then on an average, this is the second thing that I want you to note, that the interpretations are going to be on an average basis. The sales of camera would reduce. Why are the sales of camera going down in this case? Well, because you have a negative sign over here. Okay, this is another thing that I want you to be really careful about, that do take a look at the sign of the coefficients. Don't forget to take a look at this sign in a hurry. Okay, because the sign over here is negative, that's why the sales of camera would reduce by 2.375 units. Now over here, are we given any particular unit of the dependent variable? That is, are we given any particular unit of this sales variable? Well, there is no particular unit given for this variable, so I can leave it like this only. Okay, so that's your part number A. Let's move to part number B now. In the part number B, we have to construct a 95% confidence interval for the slope coefficient. And note that the confidence intervals are always constructed for the population parameters. That means we have to construct a 95% confidence interval, CI means confidence interval, for beta, because that's your population parameter over here. Okay, and let me also introduce the notation for the sample slope coefficient. So the sample slope coefficient, let me denote it by small b. So beta is going to denote your population slope coefficient, small b is going to denote sample slope coefficient. And we have to find the 95% confidence interval for beta. Note that it's given to us that all the assumptions of classical linear regression model hold good. And one of the assumptions was that the population error follows a normal distribution. Now, because we have assumed that the population error follows a normal distribution, we can argue that even the estimators are going to follow a normal distribution. That means even this B is going to follow a normal distribution if this assumption is valid, which we are given over here that all the assumptions are valid. Okay. Now, because even the estimator B will follow a normal distribution, to create this 95% confidence interval, we can work with T statistic. Okay. So the starting point is going to be that the probability that T is greater than equal to A and less than equal to B is equal to 0.95. You have 0.95 over here because we are talking about a 95% confidence interval. And let me make you understand graphically what do I mean by this A and B. So if I draw the T distribution, then because we have to form a 95% confidence interval, then this region is going to be 0.95. This is 0.025. This is 0.025. The value of T that we have over here is what I'm calling A, and the value of T that we have over here is what I'm calling B. So the probability that the T value lies between A and B is equal to 0.95. This is my starting point. Now I can easily figure out the value of A and B from the T table. But before I show you the T table, I want to discuss the degrees of freedom that we will have in this case, because that's something that you need to know if you want to take a look at the T table. So the degrees of freedom that T statistic will have is equal to n minus the total number of parameters that you have to estimate. So n minus the total number of parameters that you have in the model. Okay, so in this case, n is 17. And the total number of parameters that I have in the model are 2. The first parameter is alpha and the second parameter is beta. That means the degrees of freedom is going to be 17 minus 2 equal to 15. Now, one of the mistakes that many people do, they write the degrees of freedom as n minus total number of independent variables. That's going to be wrong because even in this equation, there is only one independent variable, okay? But the total number of parameters that you have are 2 because there is an intercept term as well. So make sure that you keep this in mind that your degrees of freedom for the T statistic is going to be n minus the total number of parameters that you have in the model. And when I say total number of parameters, I mean the intercept term as well. So that means the degrees of freedom in this case is going to be 15. Now we are all set to take a look at the T table to find the values of A and B. So this is the T table that we have. And as I showed you in the graph of the T distribution, we have to find a 95% confidence interval. That means the total area that we are going to have in both the tails combined is going to be 5%. Okay. So that means you have to take a look at this column. So this one. Okay. So in this column, in the one tail, you have 0.025. In two tails, you have 0.05. So this is the relevant column for us. And as we discussed, the degrees of freedom in our case is 15. That means the corresponding value is going to be this, 2.131. So this is the critical value that we have. Okay. Now note that the 2.131 that we got from the T table is the value of B. That is not the value of A. Reason being, over here we have 0. So B is going to take a positive value and A is going to take a negative value. So the value that we have found is the value of B, that is 2.131. Now because the T distribution is a symmetric distribution, if B is equal to 2.131, then this implies that A is equal to minus 2.131. Okay. So this is the value of A and B that we have now. So now we are going to substitute the value of A and B in this expression and then we will proceed further. So now if I substitute the values over here, then I'll get probability minus 2.131 less than equal to T less than equal to 2.131 is equal to 0.95. Now note that we have to find the 95% confidence interval for beta, that is the population slope coefficient. So we are going to substitute for T. The formula for T is equal to B, which is the estimator, minus beta, which is the population slope coefficient, divided by standard error of B. So instead of T, I'm going to substitute this now. So this implies probability minus 2.131 less than equal to B minus beta divided by standard error of B less than equal to 2.131 is equal to 0.95. Now, because we want to establish a 95% confidence interval for beta, I'm going to get rid of everything else that is over here. So I'm going to solve this equation in a manner such that I'm only left with beta in between. Okay. So what I'm going to do now is I'm going to multiply all these three terms with standard error of b. That means the first term will become minus 2.131 multiplied with standard error of b. If I multiply the second term with the standard error of b, then the denominator will get cancelled. So I'll have just this. And the third term will become this. Okay. And this is equal to 0.95. And now I'm going to subtract b from all of these terms. So if I subtract b from all of these terms, then I'll get minus 2.131 multiplied with standard error of b minus b less than equal to, now because I'm subtracting b, this b will go away. So I'll be only left with minus beta less than equal to 2.131 standard error of b minus b. And this is equal to 0.95. Now see, my purpose was to get beta over here. I'm very close to that. It's just that instead of beta, I have minus beta over here. So the last step that I'm going to do is that I'm going to multiply all these three terms with minus 1. Now, if you multiply all these three terms with minus 1, you have to be slightly careful with the way you're going to write the expression. This is because, so let me show it to you over here. So take this to be rough area over here. In this rough area, I'm going to explain one concept to you, that if you have 2 less than equal to minus beta less than equal to 3, and if you multiply all of these inequalities with minus 1, then this 2 will become minus 2, this minus beta will become beta, and this 3 will become minus 3. Now you cannot have this. Okay, so you cannot have the same signs over here because minus 2 is not less than equal to minus 3. Now you have to change the signs. So now the signs will become this. So if you multiply the expression by minus 1, the signs are going to reverse. Or there is one more way to take a look at this, that if you want to keep the same signs, then you multiply 2 with minus 1 and you write it over here. So you write minus 2 over here. You multiply 3 with minus 1 and you write minus 3 over here. And you multiply minus beta with minus 1 and the beta comes over here. Okay, so you can do it in whatever manner you feel comfortable with. It's just that be slightly careful when you multiply the terms with minus 1. I personally feel comfortable with this way of writing, so I'm going to continue with that. So I'm going to multiply this term with minus 1 and then the multiplication of this term with minus 1 will become my first term. So if I multiply this term with minus 1, I'll get b minus 2.131 standard error of b. So this becomes my first term now. Less than equal to minus beta multiplied with minus 1 is just beta. Less than equal to, now the last term is going to be the multiplication of this term with minus 1. The multiplication of this term with minus 1 will give you b plus 2.131 standard error of b equal to 0.95. Okay, so this is what we have got now. Now all we have to do is substitute the value of b and substitute the value of standard error of b, and then you will have your answer. But there is one last problem that we have over here. We do know the value of b that's given to us in the question, but they have not given us the standard error of b in the question. At least not directly. So you'll have to figure out a way to first find the standard error of b, and then you can do the substitution over here. So let's go back to the question to see the details that are given to us, and then we'll see how can we use those details to find the standard error of b. So as you can see, the value of b is equal to minus 2.375. So this is given to us directly, but we are not given standard error of b. We are given t value corresponding to this coefficient over here. Now there is one thing that you need to note over here, that this t value that's given to us is by default under the null hypothesis that the population coefficient is equal to 0. What I'm trying to say is that if you are doing hypothesis testing, okay, and let's say you have beta equal to something over here and beta not equal to something over here, then when you find the t value, you write b minus the value of beta under the null hypothesis, the value of beta under the null hypothesis divided by standard error of b, right? Now what I'm trying to say is that if you are given a t value in the question and if nothing is mentioned explicitly, then by default you have to assume that this t value is calculated under the assumption that in the null hypothesis you have 0 over here. Okay, so because nothing is mentioned, you can assume that this t value that you see over here is calculated under the null hypothesis where beta is equal to 0. That means t is equal to b minus 0 divided by standard error of b. The t value that you are given is minus 3.06. The b value that you are given is minus 2.375 minus 0 divided by standard error of b. This implies that standard error of b is equal to minus 2.375 divided by minus 3.06. And if you do this division, you will get that the standard error of b is equal to 0.776. Okay, so this is the trick to find the standard error of b in this question, where they gave you the information in the form of t and they did not give you the standard errors directly. And now we can go back to finding our 95% confidence interval. So now we know that b is equal to minus 2.375. We have found that standard error of b is 0.776. So all you have to do is put these values now. But there is one last thing that you need to be careful about. And that last thing is, when you put these values into this equation, do not write a probability statement. So what I'm trying to say is that you put the values. So minus 2.375 minus 2.131. This is multiplied with 0.776 less than equal to beta less than equal to minus 2.375 plus 2.131 multiplied with 0.776. So what I'm trying to say is that do not write probability over here and do not write that this is equal to 0.95. Now see, this is something that is related to your understanding of confidence interval. But the thing is that this expression over here is a random expression. What I mean by that is, in this expression, b is a random variable. But if you put the value of b and the standard error of b, then there is no randomness in this expression now. And if there is no randomness in this expression, that means you cannot write a probability statement over here. Okay, I'll say it once again that this is something that is related to your understanding of confidence interval. I'm not going to dive into detail and show you what actually is the meaning of a confidence interval. But for the sake of this question, let me tell you this again, that when you are writing a statement in this manner, so before you substitute for the value of b and the standard error of b, you can write a probability statement because this is a random interval and you can write a probability statement on a random interval. But once you substitute the value of b and standard error of b, then there is no randomness in the interval. Then it becomes a specific interval and you cannot write a probability statement on a specific interval. Okay, so this is something that you should definitely keep in your mind, that do not write this probability statement over here when you put in the values of b and standard error of b. Now this becomes a specific interval, and if you solve this, then you will get minus 4.02 over here less than equal to beta and less than equal to 0.721. So this is your 95% confidence interval for beta. Now let's move to the last part of this question. Now in this last part, they are asking us to interpret r square. We are given that r square is equal to 0.6452. So first I'm going to write the general interpretation of r square and then we will interpret the r square for this specific question. So the general interpretation of r square is that r square measures the percentage of the total variation in y explained by the regression model. So this is your general interpretation of r square, and in this interpretation y is your dependent variable. Now before I interpret the r square for this specific question, note that I have written total variation over here and not variance. There is a difference between variance and variation. Basically, variance is equal to variation divided by degrees of freedom. Okay, so this is the relationship between variation and variance. So if you find the variance of x, okay, then it is equal to summation of xi minus x bar whole square divided by n minus 1. This thing that you have over here is the variation in x. Okay, so this is variation in x, and if you divide the variation in x by the appropriate degrees of freedom, what you get is the variance of x. So be careful with the wording over here. In the R-square interpretation, we are explaining the total variation in y. Now in our case, we are given that R square is equal to 0.6452. So the interpretation of R square is going to be that 64.52% of the total variation in sales of cameras is explained by the regression model. Okay, is explained by the regression model. Now see, I am writing by the regression model over here, but in this case there is only one independent variable on the right hand side. So instead of writing the regression model, you can also write is explained by the variable price. Okay, because there is only one variable on the right hand side. But if you're working with a model which has many independent variables on the right hand side, then it's better to write regression model. In this case, you're working with a model which has only one independent variable on the right hand side, so you can also write explained by the variable price. Okay, so this is the interpretation of R square for this question, and with this we are done with all the parts of this question.